Let's look at final exam, question number 59, in Geometry Demystified, 2nd edition. Please refer to pages 359 and 360 and figure exam-13 at the bottom of page 359. I have drawn example C, more or less, out of that illustration. We have a plane polygon here. It lies all in a single Euclidean plane. It includes the interior, but none of the perimeter. So it's kind of an esoteric, theoretical, geometric figure that can't, well, you know, you can kind of argue. If you cut out a piece of paper, piece of cardboard, whatever, like say this paper plate, does it include its edge or not? Well, from a practical, real-world standpoint, that's kind of meaningless, but in mathematics, it does make a difference. Now let's look at what happens. Let's suppose that we include part of the perimeter of this thing. The green part, now we're including the perimeter. We include this point, but we don't include that point. So, from a practical standpoint, if we were to cut out a piece of paper in the real world, it wouldn't look any different. But mathematically, it's different semantically in this way. Now, let's just finish it up. Let's include the entire perimeter. Now, the question asks us, by including part and then all of the perimeter of this polygon, changing nothing else, keeping the interior area all there, what have we done to the actual perimeter and the actual interior area of this thing? The answer is, because this edge is infinitely thin. It doesn't look that way in this drawing, but in mathematics, it is an infinitely thin boundary. We haven't changed the perimeter or the interior area. They're still the same. A, B, and C in that figure, all the same. That's a little bit tricky, but infinitely thin lines have no area. And by increasing the area of this thing by an infinitely thin line on the outside, we really don't increase its area at all. So the answer is A.